This video is an overview of how to get access to Euclid Spectra through the IRSA tool. So I have found here a journal article that has an object that I'd like to learn more about. I'd like to get the data from the Euclid archive at IRSA for this object here. So let's go back to the IRSA homepage. I'm going to click on the Euclid icon and then Euclid Data Explorer. Let's first search for images. So I'll go to the Images tab. And remember that the yellow is the planned coverage and the red is the released data. So I'm going to paste in the target that we care about. You can see that it's in that region there. I'm going to go ahead and search. So it's going to give me back all of the imaging data that it can find. It turns out that this object is at the boundary between two Euclid tiles. That's why there's two rows there. Over here on the right, there are individual cutouts centered on my search location. The top row is all space-based data. The bottom two rows in this case are ground-based supporting data. It's more typical that you'll have just one row, just 4 images of ground-based supporting data. Now we actually want the spectra. So let's go over to the Inspect Objects tab, and it's remembered the position I put in. It's centered it here. If I ask for the default search radius, 360 arc seconds is a lot. So I'm going to just change it to 60 arc seconds. That's still going to be a lot of sources, but fewer than if I'd asked for 360 arc seconds. It's returned 437 sources. But note that the first source in the list is not necessarily the target that we asked for. This source list is not sorted by radial distance from the position that we asked for. So here's a tip for making sure that we've retrieved the source that we care about optimally. If we go back to the Images tab, these cutouts here are centered on the search position that we requested. If you want to make sure that that's the case, if you go out to the cutouts here, see how it's centered on the search target center as opposed to the table row position or the user entered position? Search target center. So that's how I know. The red sources here are the catalog that we just retrieved. So if I click on that central object, it's going to select that source from the catalog. Now, if I go back over to the catalog, look, I'm on page 2 on that source there. So that source is the one that is featured in this journal article's abstract. So if we go back over here, that's the source. How do we get the spectra? Well, over here, there's a spectrum tab. That is the spectrum. Now, one of the first things that I noticed is that there's a whole bunch of data down here that have negative fluxes. We can look at the spectrum by default as a plot, but if we go to the table view, you can see that there are some negative fluxes and some zero data. I can put a filter in here to ask it to only give me positive fluxes. Then if I go back to the spectrum, now that looks a little bit more reasonable. Here's another feature, not a bug. This is a deliberate choice. Let me explain what's going on here. This is, in essence, a list of data products. So if I go to another source off the list, I don't know if I'm going to find another spectrum or not. It says no data available. Let me go down one. Still no data available. If I go pick another source off the list and there is another spectrum, then it'll give me another spectrum. But then when I go back to the source that I care about, you can see that it has reset the filters that I imposed. That's a deliberate choice, and here's why. All of these are lists of data products. If you want your filters that you've imposed to be sticky, this is what you need to do. Pin the spectrum. Now, over here, you have a table that has pulled out that spectrum on its own, and the chart that goes with it is over here. Now, if you impose that filter is sticky. So I can go back over here to any other source in the list, any other data product in that list. If I just stab randomly, I probably am not going to find a spectrum. I'll let you, still not going to find one. But when I go back over to the pinned chart, see, it remembers the filter that I've imposed because I have pinned the spectrum. I've retained the chart, I've retained the table, and then any filters that I impose are retained. There's also some pretty nifty features here where I can, for example, impose a redshift to correct for any redshift that appears in the data. You can do some manipulations. That way you can change the units. All of that then becomes sticky in the pinned version of it. But when you go back to the list of data products, that's not sticky. All right, let's go back and make sure I've got the right source selected. Let's go back, use my trick from before, find that object in the center, then go back to the objects list. Here's that one. Okay, I'm going to select that row just so that I remember that I've got that source. I can go up here and tell it to show me a table of all the Euclid products. This is going to give me a list of all of them. And if you scroll over, you'll see that's the spectrum, and then the rest of them are all images, they're all FITS files, and they're various ancillary data. So in order to get all of these data, you can select it and then generate download script. If you want all of the data, that is all of the ancillary data, cutouts, images, spectra, everything that it's got, you just leave it all data. Then when you click download script, it's going to generate a download script for you. Then you can run that script and it will use either curl or wget to download all of the data to your local disk. You can also ask it for just a list of URLs. Then you can drop that into whatever framework you have that allows you to download it. So that is how you get access to the Spectra from the Euclid data in IRSA tools, along with some hints and tips to make it easier.